you. And the purpose of today's lecture is very important because, as you know, that you are the student of finance, and finance involves lots of numbers, and the numbers requires lots of calculations, and lots of calculation requires lots of interpretation, and lots of interpretations require that you draw some decisions based on that. So it's not just thing that we are doing it in isolation. It has a purpose. Because I last time when we spoke, and I came to know from many of you that you haven't got any formal training in statistical analysis, right? So I thought that why not organize this little workshop and we can do things together. Maybe I forgot to mention last time that bring your computers with you, but if you have, it's great. If you don't have it, that doesn't make any difference. In fact, don't let it be. It's good that you haven't brought because now you can pay attention to what I'm doing. Okay, so this is an example. First of all, to do any statistical analysis, you need some data. And usually, if some of you, I know some IB students, they would be writing the thesis in finance. I'm very optimistic. Most likely, you'll be using some quantitative data, secondary data. We do interviews also in finance, but not much. We try to get the quantitative data, and the quantitative data also we get basically secondary data. You know secondary data? The primary data is if I send you some questionnaire and you fill in and I collect from you, right? And the secondary is that I download the data from, let's say, some stock exchange or something. So the data already exists and I'm just using it, right? Now, imagine we have two companies, and the name of these two companies are Coke and Pepsi. Do you know them? Coke and Pepsi? Okay, which one do you like more? Coke? Okay. I took the stock return data, you know, the stock, and it's fictitious data. I just cooked the numbers, okay? Day one, the investor gets 21%. Day two, investor loses 30%. Day three, investor gains 5% in Coke, then lose 2% next day in Coke, 7% gain, 20% gain, and day seven, 30% loss. Yeah, you know, the investors gain and lose everything. And remember, disclaimer, these numbers are artificially bit exaggerated, okay? And then same thing for Pepsi. Whenever there's a positive, you gain. Whenever there's a negative, you are losing, right? Make sense? Okay. Before going too much, what I have done already, you might be interested in knowing that what has been the average return of an investor. So you might be interested in knowing what is the average return of investor. So if I write down mean stock return, I want to know somebody, what do you understand by the word average? What is average? The mean or the average is that we have the data and we calculate those numbers, we add them up and we find that value which is in the middle in terms of value, okay? So that is the purpose of having mean. So you might be interested in knowing that how much on an average investor gets in 7 days in stock of Coke and in stock of Pepsi. So if you are an investor, how much you gain in 1 week's time, okay? Very simple. And Excel has a beauty that it's not very sophisticated tool of analysis. Then we use SPSS and all that stuff, and people who work with me on the research level and the thesis level, I give them full training in SPSS and some other softwares, but Excel is so lovely that it's very user-friendly thing. I love Excel. Sometimes even when I'm using SPSS, I still feel like using Excel more than anything else. So what we do here, you're interested in finding what is the average performance of Coke and Pepsi, right? So what you do here, very simple, press is equal to always whenever you want to use Excel and you want to make some calculation, always start with is equal to. Otherwise, Excel will not understand your query. Excel will not understand what you want it to do. And then we do average, sorry. You see the average here? You see? Can you see the second number? So we put average, and then what we do, we select the data. So if you have this shift thing and keep selecting the data. So see, this is can you see the activity? Now Excel is active to do something. And then when you choose the data, you press enter and you find out that the mean stock return has been, yeah, so if I format the cell to percentage, no, it's a number, yeah. So too many decimals, yeah. Well, we can reduce the number of decimals, no problem. 2 decimals are enough. So you can see that we can change number of decimals, but we don't need too many. 2 are enough. Okay, so on an average, on weekly basis, if an investor start investing from day 1 to day 7, the investor has lost 1.29% overall. You know, the average. How do you know that investor has lost money? Because the sign is negative. Yeah, the sign is negative. Can I ask you one thing? Is negative always good, bad, and is positive always good? Is negative always bad? Is it bad for investor or good for investor? In Coke, bad. Why bad? Because the sign is negative. But my question is negative value always bad and positive value always good? It depends on, if it's a crime rate, imagine the crime rate, then having a negative crime rate is a good thing or bad thing? Huh? Why not? The crime rate is reducing. You can say that last year there were 200 robberies. This year there have been 100 robberies. The crime rate fell by 50%. So it's a possible. Why not? So it depends, as gentleman said, it depends upon what you are trying to analyze. And let's see what happens to Pepsi. The one option is that I do this function all over again, average, and select the data. And I find out that this is 1%, right? Is it 1%? It means that on an average, investor has gained how much? 1% in Pepsi. The other way is that I don't do it because I know that I have done the selection already. Can you see it? Because I calculated the average of this, and Pepsi is just the next column. So instead of doing this calculation, I see this plus sign here in the corner and just extend it. There we go. So we can also calculate the return like this. So on an average, investor in Pepsi has been better than the investor in Coke, because Coke, you lose money 1.29%, whereas in Pepsi, on an average, you gain 1% in 7 days' time. Yeah? How's it? All good? Okay. So mean or the average is the first average that we do. We do one more average. That average is called median. You know, have you heard the word median? What is the median? The median is that average which divides the series of data exactly in two parts without caring too much of the numbers. Okay? Do you get my point? For example, let's say I want to find what is the average money in the wallet of my students today. Is a good study? Yeah, good study, isn't it? Okay. The one way is that I check your wallets and I calculate, okay, this student, this money, this student, this money, and I add it up and divide by number of students. That would be called average or the mean pocket money. When I say median pocket money, median, look at the word median. So I can change it to median now. The median is that I make you stand in a row by the order of either least money, start from the least money and the finish at the highest money, or other way around, doesn't matter, right? And then the person who is exactly in the middle of the line, I call him or her and say, hey, how much money you have in your pocket? And that money will be called the median money. Do you understand my point? So the median is exactly in the middle. Okay, and what we do in this case, very simple. Just we have average here, right? So instead of average, I don't know why Excel, this is a bit wrong. Median is also an average, mean is also an average. But somehow Excel understand that average means mean, okay? Because it's so common. Whenever you say, hey, what is the mean value? What is the average value? People think they're same words, but actually mean is, average is more broader term than mean. Mean is an average, median is also an average. But anyway, that we don't go into that debate too much. So what we do here, again, we start with is equal to. Median, can you see median? Once you start typing letter one by one, you will see the suggestions from Excel. And the median, once again, we choose the data and press enter. What we get? What we get? 5%. And then the one option is that I type in again for Pepsi, or I simply extend it here and it comes to be 3%. So the median is 3%. Does it make sense? Can I ask you one thing? This is your original data, right? Mm-hmm. Do you see in this data 1.29% anywhere? Once again, this is your original data, right? Do you see 5% somewhere? Question once more. This is your original data of Pepsi. Do you see 1% anywhere? But do you see 3% anywhere? Why so? Why so? The reason is that when you calculate the mean, you add up the numbers, you involve the value of the numbers. But when you calculate the median, you don't involve the value of the number, you just position them. Just position them. And when you just position them, you don't make any calculation, then the number, the answer would be somewhere between the numbers of statement. Because look, in median, you haven't done any calculation. You just arrange people from highest to the lowest order or lowest to the highest order, doesn't matter. Nothing changes. Whereas in the mean values, you are adding 1 on top of 2, adding 3, adding 4, adding 5, put them all and then divide. So you are calculating in mean. You are not making any calculation in median. You are only positioning them from one order to the other order. So therefore, the numbers more or less remain same. Am I right? Good job. Here we go. That is why you can see median 5% and median 3% here. Are you fine? So these are the two averages that we use in finance very often. Questions, comments? Stefan, you have anything to add which I missed? Oh, senior, yes. Because this changes, so this changes as well. So this changes as well. So I have now one more value, E10. And then this also changes for obvious reasons. Yeah. Can you arrange these numbers in the, now your median is how much, senior? Do you have 6% in the data? Okay. Can you please can you arrange these numbers again in the order from the lowest to the highest? No, wait a sec. You have minus 30 twice. So what number you have in the, let me do it again. So we start with minus 30. We start with minus 230. Once again, minus 30. Wait, slow. Minus 2, then. Which number comes in the middle now? Okay, 5 and 7. And what's the average of 5 and 7? If somebody has 5 euros and the other person has 7 euros, what's the average? 6. Okay. What's your median? 6. So if the number of terms change, if you have the odd numbers, you know the odd numbers, 1, 3, 5, 7, 9, there would be one value in the middle. But if there are 8 people, and I ask you who sit in the center of 8 people, then the problem is 3 on this side, 3 on this side, 2 in the middle. Then you have to take the average of the 2. And in this case, there are 3 on this side, 3 on this side, and in the middle we have 5 and 7. And the average of 5 and 7 is 6. So even the median involves mean when it comes to even numbers. You know even numbers and odd numbers? I hope you know. Okay, so 5 and 7, the average, the mean is 6. That's why this time the median is not exactly the value in the data. Yep. You understand? So if it's an odd number, then the median would be one of the values in the data. But if it is an even number, then we have to be a little bit careful and we find the middle 2 numbers. Because if it is 10, 4, 4, in the middle 2, 12, 5, 5, in the middle 2, 100, 49, 49, and middle 2. So in the even numbers, there will be always 2 values in the middle. So you have to be careful. All right. I hope this makes sense. And you understand what I'm trying to say. Sorry. One more thing, I want to play a trick with you. In stock return of Coke, what is the highest value? What is the highest or the lowest value? Pay attention, it's very important point. What is the highest and what's the lowest value? Lowest is high, is minus. What if I make it minus 300? And I also make it minus 300. So I make lowest value even lower. And what is the highest value? 40. What if I make 44,000? Tell me something. Has your mean changed? Has your median changed? Why not? Sorry? Fantastic. The median has one beautiful thing, that it is not affected by the extreme numbers. So if you have a data which is extremely fluctuating, then the problem with the mean is that the mean shows something which makes no sense. Like for example, look at the mean. What's the mean? 432. Am I right? 432 approximately. 431. Okay. 431 belongs neither to this, not 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 to this. 431 belongs to nobody. But look at 6. 6 belongs to several numbers. 5 is not far away from 6. This is not far away from 6. 7 is not far away from 6. So 6 is the number which is more representative of the data. You know the meaning of word representative? Huh? You understand? Should representative be fair? Should representative be the fair number? Nice number? Genuine, unbiased? Why not? Imagine you all are laborers in a factory. And I'm the government employee, I'm the government, let's say some official, and I want to see what is the problem of the labor in my city. And instead of calling one of you, I call somebody who's a billionaire, and he tells me the labor problems. Will that be a fair interview? Will that be a fair representation of you? The person is a multimillionaire. He flies in his own personal chopper. He has a villa almost in every country in the world. And what I'm asking him, can you please explain what are the problems with the labor in the city? How does it feel that you don't even get enough water to drink during the break? How does he know that there is not even enough break for you to take rest and eat your lunch? How does he know that you don't even have mask to breathe because the factory is so polluting? So what we need to do here, the representative must be representative. So what happens in this case, 431 is not a representative of the data. 6 is. So median is more representative of the data than mean in those cases when the data is extremely fluctuating. Okay, but the tragedy is that Stefan would agree with me that in the research we use mean more than median. The idea is that mean is simple and mean is more accepted than median. Mean is more popular than. It's like you read a book and it's a it's a classic, and then you have some popular book. Popular book doesn't mean that it's a classic book. You get my point? Yeah. So one drawback of the mean is that it can be affected by the extreme numbers. The median is more modest the idea is that in the median, we don't really make any calculation. We just position the number. That's why it's not affected by the extremity of the values. Make sense? Okay. Now, I want to take you to a different situation. Yeah, so this is interesting. I'm taking you out a little bit away from finance and take you to football. You like football? How many of you like football? None of you? You like football? Do you? You like football? How many of you play? Have you ever played? You still play? Okay. All right. Let's say. Now remember that the reason I'm bringing you to football is to recheck mean. Remember, we found one problem with the mean. What is that? That the mean can be affected by the extremity of the values. Now I want to prove something else also. Imagine there are the 4 football clubs. Just in case you don't know this ESG, where is it based, ESG? Is it ESG Eindhoven in Netherlands? Yeah. And then we have Manchester United, MU, I write it. Chelsea, used to like, not anymore. Yeah, so the 4 football clubs, which, and each of them play 5 matches, right? Match 1, 2, 3, 4. And look at that. The ESG scores 25 goals in 5 matches. Then the Manchester United scored 25 goals in 5 matches. Celtic, Chelsea also scored 25 goals in 5 matches. What is the average goal scoring? If you score 25 goals in 5 matches, what is the mean? 5 goals. Pay attention to this data. Am I using too much bigger width size of, because you can't see it? Okay. Tomorrow, each team is going to play their 6th match. Which team? You can make a forecast with lots of confidence that they will score certain goals tomorrow. So you have 5 matches they have played, okay? Until today, each team scores 25 goals in 5 matches. The average goal score is 5, okay? Tomorrow, each of these 4 clubs would play a match. Can you make some prediction or forecast about each team, and about which team you can make the forecast more confidently than the other? Which team you're not very sure how much they score, but for which team you are more confident in making a forecast, and why? Anyone, please speak. Yes. Sorry. Mm-hmm. Mm-hmm. So you find it difficult to forecast for Chelsea because they can be because on one day they can be ruthless and score 17 goals against a team, but then they score nothing in many matches. And why are you so good in forecasting for ESG? Yeah, so it's more likely that they will score 5 matches tomorrow also because they are so consistent. And what about when you compare Manchester United and ESG, which one you think is more, you feel more comfortable in forecasting? Between ESG and MU, which one? ESG. There is some variation, even though it's not big variation, but there is still some variation in MU. And there is a bit more, not extreme, but bit more variation in Celtic, right? to check this phenomenon. So which one is the riskiest to forecast? And which one is the least risky to forecast? Stick with this. Variation cause risk. Now, the good news is that we have a measure to calculate risk, and that measure is called standard deviation. Have you heard this phrase before? Standard deviation is the measure of risk in statistics. Look at the word risk is a qualitative thing. I say it's a very risky place. It's a sentence, it's quality, right? But can we quantify it? Yes, we can, by using the measure of standard deviation. And how do we do it? Look at that. So we use the, when you want me to do it again, or you will see it for yourself? If you want, I can do it all together. So once again, we start with this function with this sign is equal to, yeah? Now see slowly what I'm doing. ST dev, standard deviation, right? And then we select the data, press enter. There is zero risk. Zero risk, because there's no fluctuation. There's no fluctuation at all. And then what about this one? So once I have this, you can extend the others also, but even though I have done it. Anyways, yeah. So there's a bit more, and there is extreme risk. There is 0% risk in forecasting. And then there is a 1% risk, and then there is huge risk here. Standard deviation. Standard deviation measure the scatterness of data, extremity of data. If I quickly plot these numbers, just if I take something on x-axis and on the y-axis, and I plot a line, right? Look at this line. Assume that it's a straight line. Yeah. Then, if I say that on day one, you do this, on day one, temperature is this one, day two, day three, you can easily forecast for the next days. The beauty is that it's a straight line. But now if I plot the numbers and the data is fluctuating like this, sometime plus over the average, sometime below the average, right? And then there is another data set which is like this. And then there's another data set which is even more volatile. So standard deviation is representation of the riskiness. Riskiness of what? Riskiness of volatility of data. Am I right? You understand this? Bravo. So now we go back to the spreadsheet again, and this spreadsheet will be sharing. I'll be sharing it with you after we finish the lesson. All right, same way. We may be interested in calculating is the stock return. Oh, I had more companies also, but anyways, no problem. I had BP as well. I don't know where it came from. I didn't even see it. Anyways, so you can see that. So yeah, sorry, I just go to this. So 3.88, and then I can calculate for BP as well. And then I have this S&P index. You see that index? You know what is the index? Yeah, who we compare the company's performance with the overall market average, right? Okay, same way we can do for the BP and the index as well. Anyways, standard deviation, if you want to know who is more volatile. Now we move back from football and come back to stock market. And we have the stock return of Coke, we have the Pepsi, we have the BP, 3 companies, but we also have the index. So we compare with that. Yep. And now we are using the standard deviation. Now I make it E10 because I have one. Remember, I added one more day. I'm sorry, I didn't add the day for BP. Let's make it 12%. Let's make it 9% so that it doesn't really. So yeah. Anyways, so we have standard deviation, but now we need to add one more cell because E10. Okay, and if I extend it to all the way, right? So when you look at the stock return of BP, stock return of Coke, then Pepsi, then third is BP, and the fourth is the market. Which company's investment is the riskiest? Sorry? Which one? The first one. The first one is Coke. So investment in Coke is the riskiest. Highest risk is in Coke, followed by Pepsi, followed by BP, and the overall market is not riskless, but still less risky. Yeah, 10%. Right. And then we move on to okay, which we use in quite substantially in statistics, in finance, sorry. A statistical concept that we use quite substantially in finance is called correlation. Okay, correlation highlights the degree and association between the 2 variables. I quickly stop sharing this, and then I or maybe first I explain it. Yeah, correlation is when 2 series go together. In the real life, there are many examples of correlation. For example, often we see that educated parents have educated kids. Yeah. So can I say that more the parents are educated, more kids are educated? Can we say this? It may not be always true, but there is some truth, some pattern may exist. The companies do advertisements, expenditures. You do advertisements, the companies. What do they want to do? So that the sales revenue can go up. So can we say that there is a correlation between advertisement expenses by the company and their expected sales revenue? Can we say though? Say so? Often we see that in a city where people are more educated, the crime rate is less. So can we say that there is a negative correlation between education and crime rate? Can we say that, like in Finland, in general, we believe that the state spend a lot of money on people's welfare, and as a result, people's health is good. You know, people are healthy. So can we say that there is a positive correlation between the spending by the state and people's health? Can we say that? Can we say that more intelligent you are in the field of finance, more intelligent you are in the course of statistics as well? Some correlation exists. Do you get my point? So there are many phenomena in the real life where some correlation exists. Can you give me some more example? I'm still not satisfied with this word correlation yet. I want to get some more concrete examples from you. And it doesn't have to be the finance example. You can give me any real life example. And it can be both positive or positive means when one value increase, the other also increase. Or if one decrease, the other also decrease. So they move in the same direction. And negative is that when one goes up and the other goes down. For example, as people are getting more education, we expect the crime rate to go down. As the company's managers get more training, more education, the wastage is less. As the companies spend more on R&D, the quality of output goes up. Can you see some phenomenon? So this is called correlation. The correlation is that when two or more phenomena move together. I mean, together means that there is some movement of one and the movement of other is related. It can be positive, it can be negative. For example, when I gave you the example of people getting more education and crime rate falling, it's a negative correlation. But they are correlated, isn't it? They are correlated. Similarly, more managers are qualified, educated, experienced, lesser is the wastage of resources. It's a negative correlation. More education, more expertise, wastage goes down. So in real life, there are phenomena which are correlated, positive or negative, or sometimes there's no correlation. If I simply ask you, what is the correlation between number of aircraft sold by Boeing last year and the consumption of ice cream? Do you find any correlation? There may be, but do you find any logic between these two? Correlation is also based on some logic. There's some, before you do the calculation, some common sense is based on. Now, this example is extremely nonsensical. Number of aircraft sold by Boeing last year and the consumption of ice cream in Uvascula last year. What sense it makes? Does it make any sense? Nothing. So in this case, it could be totally uncorrelated or zero correlation. All right. Sometime we are interested that are Coke and Pepsi's return related? What is a correlation? Coke and Pepsi. So in this case, what we do here, very simple, very simple, very simple. We do correlation, and correlation has a beauty that we don't need this. We don't need this. The correlation is once again, you start with this correl, do you see something? Yes, there is correlation. Here we go. And how do you choose it? You choose data 1, and then you choose second data. So you select both. Does it make sense? No. My apologies. I'm wrong. You need to first select the first whole data set, yeah, and then separate it by semicolon, and then choose the second data set. It's your choice if you want to close the bracket or not, doesn't matter, but if you press, there is a 0.98. Can you see this? It means what? There is a, first of all, always check, is the correlation positive or negative? Positive. It means that if there is a increase in the stock of Coke, there is an increase in the stock of Pepsi. Or if there's a decrease in the stock of Coke, there's a decrease in the stock of Pepsi. That is why we call it positive. And look at this. How much is the value? 0.98. Let's make it to 2 decimal places. Too much. Too many decimals. Format, number, and 2 decimals. Enough. 98 here. Can I say that Coke and Pepsi stock is 98% related? Because 0.98 means 98%. And same way, sorry, anybody want to say something? Huh? Yeah, they move together. So there's a 98% co-movement between Coke and Pepsi. Okay. Once we finish, I would be uploading this file in Moodle. Don't you worry. And then, would you be interested in knowing the correlation between let's say Pepsi and BP? Yeah. The same way we can do for Pepsi and BP as well. We don't need these rows, so why do we have them? Delete them. Okay. But this time I can't extend the formula because then it may choose wrong set. Because this time I have to remember one thing. Until now, we are only using 1 column. Yeah, 1 column for mean, median, mode, 1 column for standard deviation. But this here, we have 2 columns. So therefore, you need to pick and choose which one you want. And then if you want to find the correlation between Pepsi and BP, why not? Correl. And then we choose Pepsi. And we also choose semicolon. And then we also choose BP, but not from G2, from G3, yeah? Yeah, it can't be text. It has to be numbers. Here we go. There is a negative correlation between the two. Can you see that? There is a negative correlation. In other words, when BP, when Pepsi stock goes up, the BP goes down, and when other way around, and when Pepsi, when BP goes up, then PP goes down. Well, when BP goes up, then the Pepsi goes down. Sorry for this humbling. You get my point? So BP doesn't mean blood pressure. BP means British Petroleum. Yeah, blood pressure going up is not good. Blood pressure going down is also not good. So British Petroleum stock. So no blood pressure, British Petroleum. All right. Same way, if you are interested in finding the correlation between between, for example, Coke and BP. Any guesses? I haven't done the calculation. Any guesses? What would be the sign? What can be? What most likely is a sign of correlation between Coke and BP? Any ideas? Any guesses? Negative. You know why? Because Coke and Pepsi are 98% together. Pepsi and BP are negative. Then it's very highly likely that the Coke and BP would be negative. Is it based on some logic? Can you see the logic behind? So here we go. And we are not disappointed. The correlation is negative. So this is how we calculate the correlation between different variables. All good? Okay. Even though I thought that this concept I would discuss when we go through the slides, but I think it's a good chance that we do it now. And that concept is called regression. Have you heard the phrase regression? Regression is when one variable depends on the other. So there's a one variable. Let me explain you the theory, then we will come back to it. So I can say that if I can say that a variable y is a function of x, which means that y depends on x. So basically it means that y variable, y data depends on x data, depends on x. So y will be called as a dependent variable, and x will be called as, what is the opposite of dependent? Independent variable. So there is a mutual causation. There is a causation between the two variables. X affects Y. Examples. Input, output. The output depends on the raw material inputs. The raw material doesn't depend upon the output. You understand my point? So always input leads to output. So output depends on input. Many more examples in the real life. More hard work leads to more success. Some of the examples I gave you before in correlation are also valid here. Higher education in a city, lower is the crime rate. More product innovation, more successful the company, more profit it gets. More trained labor force in the company, lesser is the wastage. So can you see that there is one cause and the one effect variable? Okay. If I want to study this thing, if I want to find out, let's say, okay, Coke stock return. On what factor you think the Coke stock return depends on? Many factors. But a very strong factor is called the market return. And in this case, in this example, what is the market index I have taken? S&P 500. S&P 500. When on a given day, when the market is really doing great, Coke will also do good. That's what we expect. Not other way around. You can't say that if Coke performs well, then S&P performs well. No, you can't say it. But you can say that the day the market is doing good, Coke is doing good. The way the market is going down, is performing worse, the Coke is also performing worse. Can you find some cause and effect relationship? Then, if I plot it, we have Y variable and we have the X variable. So the one who depends is called Y, and the one who's affecting is called X. So that is why we say X is an independent variable or a cause variable, yeah, and Y is the dependent variable or the effect variable. All right, make sense? So imagine we plot these numbers and we find this type of curve. In mathematics, have you seen the equation of straight line? I'm sure you have done maths in the high school. And there is an equation of the straight line which says y is equal to a plus beta x. A is the intercept. This is the A intercept. And what is called beta? Beta is called slope. Good job. Beta is called slope. The slope can be very sharp. The slope can be very dull, almost nothing. And that slope can be in between. Now, have we studied risk already in finance? Which statistic measure the risk? No, total risk. Which statistic measure the risk? Remember the example of football, Chelsea, Manchester United. Which statistics? Yes. Excellent. Standard deviation. Standard deviation measures what? Risk. Total risk. Total risk. And the risk, if you see, come from two main sources. Remember we discussed in one of the lectures? Systematic risk and unsystematic risk. Do you know that? The total risk which you measure with the help of standard deviation, you can split into two parts. The one is called systematic risk. Systematic risk is that risk which comes from the market. Can I say that beta is a measure of systematic risk? Why? Because S&P is the market. The day the market does good, quite likely BP would do good. Coke would do good. The day the market is down, Coke would be down. For example, let's say in the US, the Federal Reserve Bank increased the interest rate up. As a result, the market is very bad. I mean, what is going on? As a result, S&P index goes down, and the day S&P index goes down, is very highly likely that Coke's return will also go down. So can I say that beta approximate, not exactly measures, beta approximates systematic risk or measures risk? Look at the word I said, measure, approximate. Do you see any difference between the two? Sometimes in a real life, we can't measure something, but at least we can approximate something. If I say, folks, check the welfare of people living in Uvascula, you would think so many times, hey, what is welfare? How to measure it, right? But you can look at the proxies. The bus is coming after every 10 minutes. Is it a measure of welfare? The school, and then you see that the kids are going to school walking, and then you ask somebody, hey, why are kids walking? And then somebody says, because in Uvascula, the schools are so many that the schools are only at the walking distance from the house. Everybody can actually walk to school because they're so close. There's so many schools for the kids. Is it a measure of welfare? Can you approximate welfare from this? You lost your wallet yesterday, and today you got a call from the police that they have found your wallet. Please come and collect it. Can I say it's an approximate of welfare? You've been living in Uvascula and you've been watching the parties and weekends, and you might see that, hey, people are very peaceful here, even though they're drunk, but still very peaceful. Can you call it a measure of welfare? Can you see that there is a party and the police comes, but they're not very harsh, they're very nice, and hey, guys, go to bed, sleep, it's time. Yeah, but they're not very rude. Can you call it a measure of welfare? Has it happened in the past that you've been waiting for the bus and the bus is delayed by half an hour? The buses are coming in time. Is it a measure of welfare? You go to campus and you use the public toilets, you use the cafeteria, neat and clean. Is it an approximation of welfare? Here we go. So therefore, in our life, sometimes we are able to exactly measure a phenomenon, but sometimes we get some signals, some small examples, and then we can use those examples as a case of approximation that yes, this approximates, this almost estimates, yeah? Same way, we have a measure of risk, but that's a measure of total risk, right? Can we break down the risk into systematic risk? Yes, we can approximate with what? The beta. So beta measures the systematic risk. More the beta, let's say beta is 2. And by the way, how do you know that beta is more or less? We have legends. Beta equal to 1, beta less than 1, beta more than 1. If beta is more than 1, then we say that systematic risk is very high. Which risk? Remember, don't confuse it with total risk. So I should rather use the phrase here, systematic. Systematic risk is high. If beta is close to 1, we say that it's moderate or risk neutral. And if beta is less than 1, then we say that it's a low risk. In theory, these are the categories of systematic risk, but in reality, let me make it more realistic. If your beta, let me eraser, yeah, this is eraser. In reality, if beta is less than or equal to 1, but beta is more than 0.8. So basically your beta is between 0.8 and 1. Then we say that it's a moderate risk or neutral risk, right? And if the beta is less than 0.8, yeah, then we say that the risk is low. And if beta is more than 1, we say risk is high. Now imagine you calculate beta of Coke and it comes to be 2. Then I would say, and remember beta, we never write, one thing please learn, we never write beta in percentage. Beta is always a coefficient, no percentage. If beta is 2, it means that if market goes up by 1% on a given day, Coke will go up by 2%. But by the same argument, if market is down by 1%, Coke will go down by 2%. Risky, isn't it? More sensitive. Can you see that the beta is more sensitive, more temperamental, more touchy? If the market goes up by 1%, beta goes up by 2%. You feel very happy, but don't be too happy. Next day, if market goes down by 1%, Coke will go down by 2%. Beta is risky investment. Sorry. Coke is a risky investment. Coke is only good for those people who are risk lovers. And by the way, if beta is more than 1, this investment is good for which investors? Risk lovers. If you choose beta between 0.8 and 1, then you are more like a risk neutral type of investor. Risk neutral. Well, you can take the calculated risk, but not too much. And if beta is below 0.8, then you are risk. You can call it risk haters, but we don't use the word hater. We call it risk averse. Averse means you are opposite to risk. And remember which risk we're talking about here? We're talking about the systematic risk. One thing is very important thing. Total risk, then comes systematic risk. Which risk is left now? Which risk is left now? Unsystematic risk. What are the other names of unsystematic risk? Say again. Like, you remember in the slides I mentioned also known as AKA? Please check what are the other names of unsystematic risk. It's very essential. There was one name which I mentioned in AKA, but I said, hey, I will not explain it now. I'll explain when the right time comes. And today the right time has come. Sorry? Yes, specific because it belongs to that. This I explained. What else? What else? That is done. We discussed. Then what else? Residual risk. Did you see the word residual somewhere? Residual means leftover. Now tell me something. You have total risk, right? You have market risk now. What is leftover? What is leftover then? Unsystematic risk. So it means that first you calculate the total risk of a stock. Then from there you take out systematic risk, and whatever is left out is called unsystematic risk. This is why you cannot calculate unsystematic risk, but you can only get it by subtracting systematic risk from the total risk. So this is why we also use the phrase residual risk for unsystematic risk. All right. Now you know what is systematic. Now you know what is systematic risk. It's done by beta, right? Now you know what is total risk. You do it by standard deviation. Well, just do the adjustments. You get the unsystematic risk. So simple, isn't it? I take you back to the Excel, and the last part is the beta. And I think I added one more cell, so I need to make it 10, and here also 10. Stock return depends upon the market return. And then I calculate what? And see, can you see how do we calculate the beta? Look at the word equal to slope. Remember slope, the straight line? Did you hear this word today? Slope. So just take the slope, select the data of first dependent variable, which the one who depends, separate by semicolon, and select the data of independent variable. Who's independent in this case? S&P 500. And who's dependent? Stock return of Coke. And when you press enter, it shows is Coke for which type of investor you will be if you want to pick up Coke in your portfolio? Risk neutral, but a little bit risky because it's close to 1, and so you can say risk neutral, right? And then find out Pepsi, because I need to add one more value. So I do it more value, one more. Yeah. I can do it for all others as well. Ah, I'm sorry. Yeah, this is, I need to do it for this one by one. This time I can't extend the formula because I'm using two variables, not one. About this one, what type of investor you will be? Sorry, neutral or low risk? Low risk, because it's below 0.8. What about this one? Here, the beta is negative. You are extremely risk averse investor. When the you're going opposite to the market. When market is going up, the stock of BP is going down, and the market is going down, the stock is of BP is going up. So beta can be negative also. So basically, your systematic risk can be negative also. Can systematic risk be negative? Yes, it's possible in practice. Yeah. In theory, it's not possible. It's in theory, it never be negative. But yes, in reality, it can be that beta is negative. But the point I'm trying to make here is that you can use the basic statistics to calculate the averages, how reliable the data is, lesser the standard deviation. Yeah, lesser the standard deviation, more reliable the data is. This we don't need. Do we need it actually? No, we don't need this. And this was a football example. So, don't mix up with finance, football. Okay, so you can see that the consistency of data is measured by the standard deviation. Then we also are interested in knowing the correlation between the variables. But then we want to find that out of total risk, yeah, this is the total risk. How much is the systematic risk? Okay. Remember, one basic precaution. This I can't explain now, but I will explain it in the class lecture when we meet next time. Beta leads to systematic. Beta is not a measure of systematic risk. Beta helps to calculate systematic risk. Okay? And Stefan, remember it. This phenomena we explain next time when we meet them. So beta is not just equal to systematic risk. Beta helps to calculate systematic risk, because otherwise you may misunderstand me and you will say, oh yes, Shab said that total risk minus systematic risk is called unsystematic risk. And then what you'll do, you will take this value minus this value, and then you say that, you know what, this is the unsystematic risk. But no, we need to do this little bit more next week. But all I can say at this point of time is that definitely, standard deviation is a measure of total risk. But beta helps us to find systematic risk. And once we have the systematic risk, we can simply find out the unsystematic risk. And this is exactly what we will be doing next week. All right? Any questions, comments? Do you find today's lesson useful? Very basic Excel, but with this, you not only learn how to do the calculation, but you have learned some of the very strong concepts in finance, especially this concept called beta and total risk. right? So thank you very much. I would be sharing the, the recordings as well as spreadsheet in Moodle. So wish you very best of luck, and we will catch up next week. Thank you. Take care. Bye-bye.